Hello. This video is to help you understand how temperature relates to the change in entropy of a system or a reaction. So we'll be looking at this practice problem to help you understand the trends that go on. So at 298 Kelvin, the formation of ammonia has a negative delta S of the system. So we have the equation below. N2 gas plus 3H2 gas yields 2 NH3 gas. And we can see here that the change in entropy of the system is negative 197 joules per Kelvin. So if we look at, first of all, the moles of the equation, we see that on the left side we have 4 moles and on the right side we have 2. So there is a loss in freedom of motion. So I predict that the there will be a decrease in the freedom of motion or decrease in entropy of the reaction. But that's besides the point. So for this problem, we're asked to calculate the change in entropy of the universe and to state whether the reaction occurs spontaneously at this temperature. So for this problem, we have this equation below, right here, and based off what you saw from the last slide, you notice that there will be a larger change in entropy of the surroundings at a lower temperature. For example, the ice, if you start at something like 20 Kelvin and you suddenly add heat or energy into it, then there will be a more dramatic change in entropy, right? And this is where this equation comes from. That's why T is at the bottom and the heat of the system is on top. Anyways, we'll be using this equation to solve this problem. So to start off, we first want to find this. We want to find the change in heat of the system. And for this problem, the change in heat of the system will be equal to change in heat of the reaction. And because of that, we're going to be able to solve it similarly to the way that we solved a problem trying to find our change in the entropy of the reaction. So it will appear like the following. So we start off with 2 moles of NH3 gas, right? And then again, we find the entropy. You can find that in the back of the textbook. But the entropy for NH3 is going to be negative 9.8 kilojoules per mole. And then since that's all on the product side, now we move on to the reactants, and we're going to have 3 moles of H2 times 0 kilojoules per mole plus 1 mole of N2 times 0 kilojoules per mole. Right? And this all should total to, so the delta H of the system should total to negative 91.8 kilojoules. Right? So we already have our delta H of the system, and that's what we're looking for. So we have that for equation, and then if you remember from our problem, we have the temperature as well. It is in standard condition, so that's why it's at 298 Kelvin. So now that we have that, then we can finally plug it into our equation. So back to equation, change in entropy of the surroundings is equal to negative, and then so we're gonna have 90, sorry, negative 91.8 kilojoules. Now for this equation we do need to convert kilojoules to joules, so we're just going to do that real quick. There are 1000 joules per 1 kilojoule, so we're just going to put 1000 joules kilojoule, so we're just going to multiply it by 1000 on top, and then on the bottom we're just going to have the temperature, which is 298 Kelvin, right? And then that should end up giving us 308 joules per Kelvin. This is the units that we want to end up on, right? But we're not done. Remember, the problem asked us to find the change in entropy of the universe, right? So that's what we need. So now we have change in entropy of the surroundings, and we were already given change in entropy of the system. Okay, so we're just gonna write that. So if you remember, the equation to find the change in entropy of the universe is similar as to the one for heat, but it's basically the following. So change in entropy of the system plus change in entropy of the surroundings will give us entropy of the universe. And in this case, it's just going to be negative 197 joules per Kelvin, and that was given to us, plus 308 joules per Kelvin, and this should give us 101 joules per Kelvin. So there you go. And so what this number means, it basically means that this reaction is going to occur spontaneously at 298 Kelvin. And you'll see a graph to the right of the video. But yes, thank you.